In this video, we are going to look at how you can add videos to object screens in the video game Arma 3. We will also look at how you can add actions to an object to let you control when to play, stop, and restart the videos played on an object screen. This is the second video in a series, looking at how you can add videos into the video game Arma 3. The first video touched on how to play videos directly on the screen for specific players or all players. We did also take a look at how you could control the size of the video shown on the screen. So, the first thing we need is a video to play, and that video needs to be in the OGV file format. If you don't know how to get your video into the OGV file format, I recommend watching the beginning of the previous video. So, when you have your video ready in the OGV file format, you can just paste the video file inside the mission folder for your mission. But if you want your mission folder to be a little more cleaner, you can create a new folder inside mission folder. Name it video, for example, and place your video file inside that folder. And that's what I want. So I will move the OGV video file with reception inside the folder called video. Now we have the video file. We can then create the script file. I also want this file to be a function for easier use in multiplayer. So we are going to set it up as a function from the start. So head back into your mission folder. Here we are going to create a folder named functions. Then enter this folder. And inside it, we are again going to create a folder. And this one should be named play video category. Now, inside this folder, we are going to create our SQF script file. You can name this mostly whatever you want, so long it has the prefix fn underscore at the beginning of the name. I'm going to name this file fn underscore play film SQF. Open the file you have newly created. Inside here, the first thing we are going to do is to create a local variable. This local variable is going to represent the screen we want to play the video on. And by making it a local variable, it will let us reuse the script. So, start by writing this. Underscore screen equal underscore this select 0 semicolon. Underscore screen is going to be our local variable. Equal will define this local variable as the following given argument. Underscore this is a magic variable, and in our case will be an array containing the arguments given when calling this function. Select is a command where we select an element from the given array. The elements selected are based on the position or condition given. In our case, select will select an element from the array created when calling this function. 0. This is the position of the element in the given array we want the command select to select. The position in the array starts with the number 0, not 1. So the first element in the array will have the position 0. So, our local variable underscore screen is going to be defined as the first argument given when calling this function. And this lets us reuse this command for more than one object. Now, after this local variable, we are going to create another local variable. This local variable is going to be the path to the video file. The path starts with the mission folder and then goes from there. So for example, if you placed the video file inside the mission folder, the only thing written here should be the name of the video file. Since I did create a folder called video inside the mission folder and did put the video file inside that folder, I have to add a folder before the file name in the path. So it should look something like this. Underscore video equal question mark video backslash videoception point ogv question mark semicolon. if I just had let the video be inside the mission folder, then I would not have needed to add the folder name in the path, and could have written it like this. But I need to write it like this. Now we have defined the two local variables we want to use. Now it's time to use them. Our next code line in the script is going to be the command setObjectTexture. And that command looks like this. Object setObjectTexture square bracket selection, comma, texture square bracket semicolon. Object is the target of the command and will be the object a change in the texture we happen to. setObjectTexture is the command and will set the given texture of the part of the object. Selection. This can be a number or a string. A number indicates the selection position in the array of hidden selections, which can be found by using the config viewer on the object. String refers directly to the name of the selection in the hidden selection array, and this too can be found by using the config viewer on the object. Elements in the array indicate what can be retextured inside a running game. But it's not really straightforward with this, since similar elements can have different string names on different objects. For example, this PC will have the screen element as the only element in the array, so the position number will be 0 and its string name is camo_1. Meanwhile, regular laptop will have two elements, where the body is the first element in the array and the screen is the second element in the array, meaning one need to use one to scope to the screen. But it gets worse. Camo_1 will here refer to the body of the laptop. Meanwhile, the screen will be called screen_1. Then we have laptop. This has only one element, and that is screen again. But its string name is camo. This making setting a texture on an object not really easy. Texture. This is the path for the texture you want to set on the object. The texture must be in the resolution of 2 raised to the power of a times 2 raised to the power of b, where 4096 times 4096 is the biggest resolution supported. Supported formats for textures are PAC, PA, JPEG, JPEG, OGG, and OGV. So, we are going to write the command like this: _screen setObjectTexture square bracket 0, comma, _video square bracket semicolon. _screen. We want that the object we assign to our local variable _screen to be our object. 0. In our first case, we are going for an object where the screen is the first element of possible elements. If you know you are going to use another object with another element order, you can change the number 0 to a fitting number. _video. For what we are going for, we need to assign the video as the texture. If we run the mission now and code on this code, we will see that nothing happens. We have set the video as the texture, but the video will not play. So we need a way to play the video to see the change. To get the video to be played, we need to use the function bis_fnc_play video. And if you have watched my last video, touching on how to play videos in Arma 3, you know that this function is the same function one used to play videos on the screen. The function looks like this. square bracket, video path, comma, size, comma, FG color, comma, skip var name, comma, biggie color, comma, keep aspect, square bracket, call, bis underscore fnc underscore play video, semicolon. In our case, we are only interested in video path, size, and the skip warname arguments. The auto arguments are we not going to dive into in this video, but if you are interested in them, I recommend watching the video How to Play Videos in Arma 3. So we can cut down the code line to this. Video path. This one is a string. It is here you write in the file path and the file name of the video file you want to play. Size. This is an array consisting of 4 variables. The first variable is the position of the left border of the screen. The second variable is the position of the top border of the screen. The third variable is the width of the screen, and the fourth variable is the height of the screen. FG color. This too is an array. This array defines the foreground color of the video and is in the format of RGBA. Since the last argument we need is after this argument, in our case we need to add this argument. Skip var name. This is a string. Here is where one places down the variable name the function should check for if it's true to skip the video, also stopping the video. For the video path, we will insert the local variable underscore video, with the value set to be the path to the video we want to use. Then for size, we have lot of options to change it here. We can either change one or both of the 2 first arguments in this array. This means changing the position of the video played on our screen. Or we can change the 2 last arguments in the array, changing the size of the video. That is what I am going to do, setting the size of the video to be 0. So here I'm going to write square bracket 1, 1, 0, 0, square bracket. After this, we have the color of the video on the screen. I am not interested in this since this don't do anything in our case, since we are interested in the video played on the object instead. But since I am interested in the argument after this, I need to put something in here to reach the next argument. So I'm going to fill in square bracket 1, 1, 1, 1, square bracket here, since this is the base attributes to this array. Now, for the skip variable name, I am going to write tyst underscore stop film. You could give it a unique name yourself, just remember that name, because we want to use it later. This is also a string, so it needs to have question marks. So with this, the code line should read as follows. Square bracket, underscore, video, comma, square bracket, 1, 1, 0, 0, square bracket, comma, square bracket, 1, 1, 1, 1, square bracket, comma, question mark, tyst underscore stop film, question mark, square bracket, call bis underscore fnc underscore play video, semicolon. Now we have finished the code inside the script file. The next thing to do is to set this file up as a function. So head back into the mission folder. Here we want to have an ext file called description. If you don't have one, just create one. Now open that file. Inside this file, we are going to define the SQF file we recently created as a function. But before we can do that, we need to create a class called sfkeyFunctions. If you don't have that one already, to create it, just write class sfkeyFunctions brushes and at the end semicolon. Next, inside this class, we are going to create another class. This class is the tag class, and this will normally define the tag who is going to be the prefix of the function we are creating. A good practice is that the tag should be unique for you. Don't use tags like this or some mods tag. A tag could be short to only 2 characters to 8 characters long. It can be composed of letters and numbers, but the letters must be uppercase and the tag must start with a letter. Usually in my tutorials I use tyst, and I am going to use it here too. So the setup is similar to before. Start with class, then put down your tag here. Then, after writing the tag, place down some brushes and end it with semicolon. After this, inside the tag class, we are going to create another class. This class is going to be the category class, and this will define the function's category in the function viewer. And normally, the category folder the function will be loaded from. Like previous, start with class, then the name of the category folder we created previous, so play video category, and then add some brushes and semicolon. Then inside this class, we are going to create our last class. This class will be the function itself, and you should use the name of the file we created earlier, but without the fn underscore prefix. So we start like the previous classes, with class, then the function name, but not any brushes, instead just semicolon. And that's it for defining a function. So now at the mission start, this script will now be compiled and saved as a function. If you are using a script many times, it is recommended to turn it into a function for better performance. In our case, it may, but it will also make it easier to run the script in a multiplayer setting. Now, we are going to do a fast check of our code. So head into the Eden editor and place down, for example, rugged screen. Then click on it and give it a variable name. I am going to name it Ushi underscore screen. Then place down a trigger. Set it to be radio trigger, alpha, for example. Then inside the on activation field, drop this line. Square bracket, Ushi underscore screen, square bracket, spawn, tyst underscore fnc underscore play film, semicolon. Here in our argument we have added our object. This is the object the video is going to be played on. In our case, rugged screen has its screen set to be the first element in its hidden section array. Then we are calling on the function we made. Since I wrote tyst as my tag, tyst is going to be the tag prefix of this function. After the tag, we have fnc here, instead of fn, who is the prefix in front of the function file. And at the end, we have the function name. With this, if I trigger this trigger, the video should get played. Take note, The object will not play any sounds, and any sounds from the video will be played without any direction sources, since this sound is really coming from the video who is getting played on our screen.
Choosing a screen with the texture setting in object specific will making things easier. After that, paste your video and picture inside the mission folder. The video should be of the OGV file type, and the picture can be off PAA or JPEG. Then place down a trigger, set it to and show the activation time. Then in the on activation field, you drop this code, spawn. Video, shock, video file, .ogv. Saver, shock, picture file, paw, Oshi screen. Set object texture. 0, video, 10, call, biz, FNC, play. Video, sleep, 6, Oshi screen. Set object texture. 0, saver, and start the mission.
The code works, but we can see that the video may still be on the texture of the object. What may be a little more problematic is if I run this code on another object, for example like this. Then you will see that the video will also start playing on the object again.
Choosing a screen with the texture. Do you want to share your Oshi to the masses?
Even if the video is another one. So this is something I don't want. So I will head back to the script file fn_play film and add this code line after the last line in the script. Underscore screen set object texture square bracket 0, question mark hashtag reset question mark square bracket semicolon. This line of code will reset the texture of the screen to its base texture, but most of the time it's black, removing the video from the object when it's finished, preventing the object to play the video or another. If another biz_fnc_play video is run for something else. We have now created the base function. We can now take a look at how to create the actions we want to attach to an object. For this, we are going to head back into our function folder. Here, we are going to create a new folder. I'm going to name it actions category, but you can name it whatever you want, just to remember that name later. Now, head into the newly created folder. Here, we are going to create a new SQF file called fn_action play video. As before, so long you have the prefix fn_ in front of the name, you can name it whatever you want. Now open this file. The first thing we are going to do now inside this file is to create a local variable. This local variable is going to also represent the screen we are going to play the video on. So it's going to have the same setup as the previous _screen local variable. _screen equal _this select 0 semicolon. Now we are going to use the command addAction. This command will add an action to the action menu, the scroll menu of an object. So the command looks like this. Target addAction square bracket question mark title question mark comma brushes script semicolon brushes comma arguments comma priority comma show window comma hide on use comma question mark shortcut question mark comma question mark condition question mark comma radius comma unconscious comma question mark selection question mark comma question mark memory point question mark square bracket semicolon. Target is the object to which the action will be added to. This may be a unit, vehicle, or a static object. Simple objects and agents are not valid targets for adding actions. addAction is the command creating an action one can select from the scroll menu. It has a local effect, meaning the command itself and the effect from the script in the action will only happen on the machine the code is run. But it has a global argument, meaning the argument it uses can be from another machine. Title. This is a string and is the text that will appear in the action menu and possibly on the screen, indicating the action is available to the player. Next, we have the script, where we define what will happen when the action is triggered. For example, we can call a function, spawn a script, or place the raw code here. There are 4 parameters we can use to make the things easier for us. Underscore this select 0 scopes to the object the action is assigned to. Underscore this select 1 scopes to the caller of the action. Underscore this select 2 scopes to the action ID. Underscore this select 3 scopes to the argument set in the next parameter of the script. After the script, we have arguments, which are passed to the script and can be selected with underscore this select 3. Priority. This is a number and determines the actions order in the action list. A higher priority means the action will appear higher up and be pushed on the screen when looking at the object. If 2 actions have the same priority, the newest action will appear below the older one. The value can be a negative number and include decimals. Show window is a Boolean parameter that can be either true or false, with true as the default. When true, the action will be displayed on the screen with its title when available. If false, the action is only shown in the scroll menu. Hide news is also a Boolean parameter, true by default. When true, the scroll menu will be hidden if the action is activated. If false, the menu will remain open and the action will be highlighted after activation. Shortcut. This is a string and allows you to assign a specific key action to this action. For example, if you write down compass here, then when the players meet the condition for performing this action and press their keyboard key for the compass, the action will be triggered. Condition. This is also a string and sets the requirement for when the action can be shown and activated, with the default value being true. For the action to be displayed, the condition must return true. 4 arguments can assist in defining the condition. Underscore target scopes to the object the action is assigned to. If the object is a unit inside a vehicle, the vehicle becomes underscore target. Underscore this scopes to the player who has this action registered to them. Underscore original target scopes to the object the action is originally assigned to. Unlike underscore target, these scopes do not change if the object is a unit inside a vehicle. It still scopes to the unit. Underscore action ID returns the action ID. Radius. This is a number and is the distance between the activating player's position and the object's position, with a hard-coded maximum limit of 50 meters. The default value is also 50 meters. Unconscious is a Boolean parameter, false by default. If false, this action will not be shown to players who are unconscious. Selection specifies the object's geometric level of detail, LOD, where the action will be placed. Memory point specifies the object's memory level of theta, where the action will be placed. In our case, we are mostly interested in the following arguments: title, script, condition, and radius. If we only had cared for title and script, we could have cut a lot of these arguments. But since we want the action to be limited to a certain distance to the object, we also need to write down all the arguments up to radius. Now, the object we want the action to be added to is the screen we want to play the video on. Therefore, we are going to use the local variable we recently created, so we will write _screen at the start. We follow this with the addAction command and a pair of square brackets and one semicolon. Then inside the square bracket, we are going to add arguments for the command. We start with adding the title. I am going to name it play video. Since this is a string, it needs to have a question mark at the start and the end of the text. Then, after having written the title, we end the line with a comma. Following the title, we want to add the code firing when the action is called. We will start by creating a pair of curly brackets, and at the end of the curly brackets, put down a comma. Then, inside the curly brackets, we are going to add this line: _target equal _this select 0 semicolon. We can define the 4 parameters who are connected to the action, but in our case, we are only interested in the first parameter. So we are just going to define that and assign it to the local variable _target. The next step inside the code is that we want to add the command remoteExec. This command will remote execute a given order. Our order is going to be the function we created in the previous file, tyst_fnc_play film. We want to remote execute this function because the script inside the function and the code in the action we are creating has a local effect. Meaning, if we don't remote execute the function and just calling the function inside this action, the video will just be played for the player activating the action. And that is something I don't want. So the next line of code will look like this: square bracket _target square bracket remoteExec square bracket question mark tyst_fnc_play film question mark comma underscore nearby players square bracket semicolon. The value of _target is the object the action is assigned to, who in our case is the screen we want to play the video on. In the script of the function who we made earlier, we also did make a local variable who we want to have the value to be this object. We did write it so the local variable is defined as the first argument given. So we add _target as the parameter to this command to move the value over to the other function. Then remoteExec is used in our case to tell the server to execute the given function on specific machines. The function in this case is the function we created earlier, tyst_fnc_play film. After the function, we have the targets. This defines what machines the function should be executed on. We want other players to be enabled to see the video when a player uses the action, so we want to send it to them. We could choose to use 0 here or leave it blank, since 0 is the default value. 0 in this case will mean that every machine, both server and client, will get this function fired on their side. But this will mean that everyone will get this video played for them, and if there is audio in the video, they will hear it, regardless of the distance from the object. So we are going to create a list of players who are close to the object and then execute this function only for them. So over this script line, we are going to create a new line. It starts with underscore neighbor players, so it's going to be a local variable with this name. Then we are going to write equal and so add the command all players. This will return an array of all players in a mission, including both real players and headless clients. We are going to use the command select after this. So we are going to select something out of the all players array based on the condition we are going to create. Follow the select command with a pair of curly brackets and a semicolon. Inside the curly brackets, we are going to write our condition for what the select command should go after. We will first start the condition with a magic variable called _x. This is an engine maintained variable. In this instance, this will represent the current element of the list who are getting checked. Then we will follow that up with the command inArea. This will check if the given element's position is inside the given area. If so, it will return true. After inArea, write down a pair of square brackets. Inside this pair of square brackets, we are going to put down the local variable _target again. We want the screen to be the center of the checked area. Then we are going to put down a comma, then 15, and a new comma, and a new 15. This true 15s is representing the radius in x and y direction of the axis. So now there is going to be a 30 times 30 square around the screen, where the screen is the center. The script line should look like this. Underscore nearby players equal all players select brushes underscore x inArea square bracket underscore target comma 15 comma 15 square bracket brushes semicolon. Any players inside this area when the action is activated will be put inside this list named underscore nearby players. This list will then be used to send the function to their respective machines. Now, we are going to write in the next code line. This line will create a variable called tyst underscore nearby players with the value of underscore nearby players connected to the targeted screen. The reason for why I'm doing this is to create a blocker for this action and save the players who has the video playing. So the code will look like this. Underscore target set variable square bracket question mark tyst underscore nearby players question mark comma underscore nearby players comma true square brackets semicolon. I will copy this code and paste it in. Then I change the first value to nil. When nil is set as its value, the variable will get removed from the object when this code runs. The reason for why I have this code at the end is so the blocker will get removed when the video has finished. And when the video is done, there is no reason to have the players saved. But to get that to happen, I will need to add a sleep command between these two codes. So go up a line and write in a sleep statement. Since the video I want to play is around 60 seconds long, I will add the number 60 after the sleep command, and then end the line with a semicolon. With this, we have finished the script inside the action. We can now move over to our next argument. We don't have any interest in any auto arguments sent to the script part of the section, so we are going to write nil here and comma. The next argument is the priority of the section. Again, there's no real interest in this argument in this case, So we are going to put down the default value 1.5 and follow it with a comma. Then we have the show window argument. Again, now this is no real interest for us. So I am going to use the default value true here and follow it with a comma. We have after that argument the hide unuse argument. Again, no interest. So I am going to put down the default value true here too and a comma. Then we have the shortcut argument. This too I don't have any interest in. So I am going to put down the default value, an empty string, so a pair of question marks, and follow it up with a comma. Then we have the condition. This should be written as a string too. So question marks and end the line with a comma. Inside the question marks, we are going to drop this code. 0 equal count parenthesis underscore target get variable square bracket apostrophe tyst underscore nearby player apostrophe comma square bracket parenthesis. So what we are checking for in our condition is that the variable tyst underscore nearby players will be set in the code run when the action is activated or an empty array. And if it is an empty array, our condition will return true. But if it's not an empty array, it will return false. So when the code is run, the condition for the action will return false, and the action will be blocked from being shown and activated. But when the timer is run out, the variable is going to get removed, and when checked, this will lead to that the default value will instead be returned, and that is an empty array, leading to the condition being true again. Take note, since the condition must be written as a string, and therefore we use question marks, we can't use question mark to identify strings inside the string. Therefore, if we have a string we are going inside the condition, like for example the name of the variable here, we need to use apostrophe instead. Then we have arrived at our last argument, the radius. The default value here is 50 meters. I want it to be around 1 meter. So I'm going to put down the number 1 here, and that is with action. We don't need to fill out the auto arguments and can leave the script looking like this. This will create an action connected to the object that we pass as an argument when calling the script. The condition for the action is that the object has no saved array of players, and it will appear for the players only when they are within 1 meter of the object. When activated, the code will create a list of all players inside a square area around the screen and then call the function that plays the video for the players in that list. This list will be saved to the object. After 1 minute, however, this list should be removed. Break. Future Tarva there. There are some problematic things about the code, not game breaking, but it may lead to things not working in the way we want. So let's talk about the issues. The script will be executed when the action is activated or executed in a schedule environment. We use sleep to hold the last code line until our video has finished playing. The problem arises when we introduce another way to end the video instead of letting it play out. Because the script called with action will still run. The code will be sleeping out the remaining time and then execute the last part. And this break or check, because this last part can still be running when someone else starts the video again, right after stopping it. My first solution was to replace the sleep statement with a wait until statement. Checking for if the player's mission namespace has the same variable, we will stop the video, or if the difference between the game time recorded right before the statement and the game time when checked is over 60 seconds. But that are what I would call a hot lösning, a hate solution. We will still get this code firing twice when someone stops the video. It will just happen very close to each other, hopefully. It may also lag a little after and create the same problem as before. So what I want is to prevent this code from being fired if someone has, for example, stopped the video or stopped and started the video again. My second solution is what I have landed on. Here I'm going to create another variable. Use it to check if someone else had tampered with the playing of the video on the object. Then I am going to create an if-then statement after the sleep statement and move the last code line inside the then code. So if the variable returns as the same as it was saved when the action was activated, then the code will be fired. But if someone has tampered with the playing of the video on the object, the code will not run. We will start by inserting a new code line over the sleep statement. The line should read as follows: underscore target set variable square bracket question mark tyst underscore activation value question mark comma time comma true square bracket semicolon. This code line will attach a variable to the object. The variable is going to be named tyst underscore activation value, and its value is going to be the game time after the moment when the variable value is set, and the variable is going to be a public variable. By using time as a value, it will let us make a variable with a dynamic unique value. After this code line, we are going to insert a new one. This one is going to create a local variable with the value of the recently created variable attached to the object. And the code line should read as this: underscore saved value equal underscore target get variable question mark tyst underscore activation value question mark semicolon. With this we have set up the variable used to check if there has been some tampering. Now we can head down to the last code line in the script part of the sleep statement. We are going to create an if-then statement here and move this code line inside the then statement. After that, we can head into the if condition. Here, inside the if condition, we are going to set up this statement. Underscore saved value equal parenthesis target get variable square bracket question mark tyst underscore activation value question mark comma 0 square bracket parenthesis. So here we are checking if the saved value is the same as the value we get from the variable when we are checking the variable again after the sleep. If the variable is changed, then the variable will not return the same value as the local variable, and the if condition will return false. But if the variable has not changed, it will return the same value as the local variable, and the if condition will return true. And this should fix our problem. Our next step is now to create the action to stop the video from being played. What we are going to do is to copy the code we finished created and paste it in under the copied code. Here, I am going to replace the title with like and subscribe, but you could write it to be stop video. But I'm going to stay with like and subscribe. Then we can head into the script part of the action code. We are not going to touch the first code line we have, the code line for the parameter, but we are going to touch the code line for the local variable underscore nearby players. This one we are going to rewrite. So instead of selecting from all players, we are going to define underscore nearby players as the value of the variable tyst underscore nearby players, who are the variable we set to the object in our previous action. So write this line as follows: underscore nearby players equal underscore target get variable square bracket question mark tyst underscore nearby players question mark comma square bracket square bracket square bracket semicolon. Then we can go down to the next code line, the remoteExec code. This one we also want to rewrite. So instead of underscore target, we are going to write in mission namespace. Following mission namespace, we are going to add a comma and then a pair of square brackets. Inside the new pair of square brackets, we are going to write in the name for the skip variable we created in the previous function. It was named tyst underscore stop film. This variable name is a string, so it should have question marks around it. Then we add a comma after the variable name and then write in true. This is not a string. Now we have replaced the parameters. We can now head to the order of the remoteExec command. Instead of having the name of the function we created earlier, we are going to have the command setVariable. So replace tyst underscore fnc underscore playfilm with setVariable. The code line should then look like this: square bracket mission namespace comma square bracket question mark tyst underscore stop film question mark comma true square bracket remoteExec square bracket question mark setVariable question mark comma underscore nearby players square bracket semicolon. This will remote execute a setVariable command would look like this. To the players who can be found on the list underscore nearby players. But why do I remote execute the setVariable command? We can, with a third parameter, set the variable to be public in the setVariable command. We did that earlier. But we can't call it with the same precision like the remoteExecute command. We can use machine ID, but it's kind of hard to get the machine IDs for other machines beside the local machine and the server. But if we remoteExecute the command, we can create a list of players we want it to happen to. And why do I want it to happen to specific players? The reason is because maybe two different groups start and play the video on two locations. Having the action to be global can lead to that the one group can stop the video for the other group. The next line can we remove. Then we can ignore this line about setting the value on the variable we are using to check if someone has tampered with the actions on the object. Because this works as we want it to overwrite the value of the variable on the object. But the line after that one can we remove. And we can change the sleep time from 60 to 1. Now we have this if-then statement. In this script part, we are only interested in the code inside the then statement. So grep that out and remove the rest of the if-then statement. Because we want also this variable to be removed from the object. After this, head back up. We want to copy the code line with remoteExec, the stop variable. Paste it in on the sleep line. Then, inside the parameter array to the newly pasted line, replace the true statement with nil. This will make it so the variable who was recently set to true will get set to nothing again, and that make it so you can start to play the video again. Now we are finished with the changes in the code part. We want to do one little change in the condition before we are finished. and that is changing out the first equal sign with an exclamation sign. This will say the condition for showing this action is that the value of the variable test_neighbor players is not equal to 0. So the array must contain some players. With that, the code should read like this. And that is with the changes. The script inside this script is now finished. We can now declare this script as a function too. So let us head back into the description.ext file. I am going to place this function inside the same tag group as the previous function. So the tag used to call on this function should also be test. But I am going to create a new category class inside the tag class. This category class is going to be named actions category, since I named the folder where I created the file action category. Then inside this class I am going to create a new class and name it action play video. If you have named this file another name, just write that name here without the fn_ prefix. We have now declared the script as a function too. We can now create a file who is calling on these functions. So head into the mission folder. Here we're going to create an initPlayerLocal.sqf file. This file will be executed locally on each player's machines, either at mission start or later when they join the mission in progress. Now open this file, and inside this file write this line: square bracket OC_screen square bracket core test_fnc_action play video semicolon. OC_screen is the variable name for the screen I want to use. It is the screen I placed down earlier when testing our first script. You can replace the variable name of your screen or screens here. The command call will execute the function in this environment. The function is the script we made earlier. If I boot up the game now, you will see that I have an action named play video when looking at the screen. Activating it will make the video play for us.
Do you want to share
If I so chose the action like and subscribe, the video ends for both of us.
Do you want to share your Oshi to the
Now,
masses?
my other player
Easy steps.
runs the distance from me. And when I chose the play video action again, the video is playing for only me. I hope you now understand how to play a video on an object in the game, how to add action to an object and make it so interacting with action make a video play for a specific group, and how you can make an interaction stop a video playing for a specific group. You should also know how to make a function. Sadly, there's no way to choose where in the video should start. Meaning starting the video again will make the video start from the beginning. Also, these videos will play their sound without being 3D positional. The audio will not come from the object, but will be played like if you have played a song for the players. If you are interested in how you can make a video on an object with a 3D positional audio, I will shout out Hackett's video tutorial on that. Links are in the description. Thank you for watching. If you have questions or want more information, feel free to leave a comment about it.